Welcome friends, this is Dr. Sangram Patil and let's start with second part of chapter 2 periodic classification of elements. If you haven't already seen part 1, go to the YouTube channel and first go through part 1 and then start part 2. We have started looking at Mendeleev's periodic table and we have seen merits, that is advantages of it in the first part, and now this is demerits of Mendeleev's periodic table. So the demerits are the whole number of atomic mass of the elements like cobalt and nickel is same. Therefore, there was an ambiguity regarding their sequence in Mendeleev's periodic table. That is confusion regarding their sequence, cobalt and nickel. The second demerit is isotopes were discovered long time after Mendeleev actually put them in periodic table. As the isotopes have the same chemical properties but different atomic masses, a challenge was posed in placing them in Mendeleev's periodic table. It was difficult to find position for these isotopes. Third demerit, when elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. It was not possible to predict how many elements could be discovered between two heavy elements, because the increase in atomic masses was not uniform. So that was a problem. Fourth, the position of the hydrogen. Hydrogen shows similarity to halogens. Halogens, they come in group 7. For example, molecular formula of hydrogen is H2, while the molecular formulae of fluorine and chlorine are F2 and Cl2, respectively. In the same way, there is a similarity in the chemical properties of hydrogen and alkali metals, that is group 1. There is a similarity in the molecular formulae of the compounds of hydrogen alkali metals, which are sodium, potassium, etc. And these metals, they are actually formed with chlorine and oxygen. On considering the above properties, it cannot be decided whether the correct position of hydrogen is in the group of alkali metals, that is group 1, or in the group of halogens, that is group 7. So these are the difficulties encountered when you want to put all the elements in Mendeleev's periodic table. So these are demerits, disadvantages. Now if you look at this table, adjacent tables, it gives you compounds of hydrogen and compounds of sodium. So that's similarity in hydrogen and alkali metals. So study them well. And the table 2.6 gives you similarities between hydrogen and halogens. So it's shown the molecules H2Cl2 on the left side, and then compounds with metal are sodium hydroxide, sodium chloride, and compounds with non-metals are CH4, that is methane, and CCl4, that is carbon tetrachloride. Now there are a few questions here. Let's go through them. Write the molecular formulae of oxides of the following elements by referring to the Mendeleev's periodic table. I'll just read out the answer. Sodium is Na2O, SiO2, CaO, CO2, BaO. Phosphorus, it is P2O5. For Cl, it's Cl2O7. Let's move on to the next one. Write the molecular formulae of the compounds of the following elements with hydrogen by referring to Mendeleev's periodic table. So it wants the answer chemical formulae of these compounds with hydrogen. CH4, that is methane, H2S, that is hydrogen sulfide, HBr, that's hydrobromic acid, AsH3, arsenic hydride, HF, hydrogen fluoride, H2O, that is water, it's also called as dihydrogen oxide, NH3, ammonia, and HCl, that is hydrochloric acid. Friends, now let's move on to the modern periodic law. We have looked at Mendeleev's periodic table. The scientific world didn't know about the interior structure of atom when Mendeleev actually proposed his periodic table. But once the electrons were discovered, scientists started exploring the relationship between the electron number of atom and the actual atomic number. The atomic number in Mendeleev's periodic table only indicated the serial number of the element. So in 1913, the English scientist Henry Moseley had demonstrated with the help of experiments using X-ray tube that atomic number, that is symbol Z of an element, corresponds to the positive charge on the nucleus or the number of protons in the nucleus of atom of an element. This revealed that atomic number is a more fundamental property of an element than its atomic mass, and according to the statement of the modern periodic law was then made as properties of elements are periodic function of their atomic numbers. Now let's learn more about modern periodic table. Long form of periodic table. The classification of elements resulting from an arrangement of the elements in an increasing order of their atomic numbers is the modern periodic table. I'll read it again. It is the classification of elements resulting from an arrangement of the elements in an increasing order of their atomic numbers is the modern periodic table. The properties of elements can be predicted more accurately with the help of modern periodic table formed on the basis of atomic numbers. The modern periodic table is also called the long form of periodic table. In the modern periodic table, the elements are arranged in accordance with their atomic number. Have a look at this table now. This is a modern periodic table, and there's a symbol for each element, and they are arranged in accordance with their atomic numbers, and the name of the element is written under each symbol, and there is a mention of atomic mass as well. This table is very important. I would suggest you make a copy of this, photocopy Xerox, and put it on the wall, on the board where you study, and have a look at it repeatedly. It's a very important table. So now we know that there were drawbacks in Mendeleev's periodic table system. This modern system has removed those drawbacks. However, the ambiguity about position of hydrogen is not removed even in modern periodic table. This is an important point to note. Now, we saw last year that electronic configuration of an atom, the way in which the electrons are distributed in shells around the nucleus of an atom, that's determined by the total number of electrons in atom. And the total number of electrons in an atom is same as the atomic number. The relation between atomic number of an element and its electronic configuration is clearly seen in modern periodic table, which is not seen in Mendeleev's periodic table. Now, structure of modern periodic table. The modern periodic table contains 7 horizontal rows, and these horizontal rows from left to right are called periods, and they are 1 to 7. Similarly, The 18 vertical columns from above down in this table are called groups, and they are 1 to 18. The arrangement of the periods and groups results into formation of boxes. Atomic numbers are serially indicated in upper part of these boxes. Each box corresponds to the place for one element. Now let us look at the questions given here. The position of the elements in the periodic elements. Now, first question, how is the problem regarding position of cobalt 59 and nickel 59 in Mendeleev's periodic table resolved in modern periodic table? In modern periodic table, friends, cobalt with lower atomic number, that is 27, comes first, and then nickel with higher atomic number, 28. Even if their atomic mass is same, that is 59 for both nickel and cobalt. Second question, how did the position of chlorine 3517 and chlorine 3717 get fixed in modern periodic table? Now this issue of chlorine 3517 and chlorine 3717 is fixed because the modern periodic table is based on atomic number of element, whereas in Mendeleev's periodic table the properties of the elements are the function of atomic masses. That's why they were unable to ensure the correct position of chlorine 35 and chlorine 37. The third question is, can there be an element with atomic mass 53 or 54 in between the two elements chromium 5224 and manganese Mn 5525? Now, friends, this is quite clear. This is not possible to have element with atomic masses 53 or 54 between these two elements chromium and manganese because their atomic numbers are continuous. There cannot be an element between them. The fourth question is, what do you think should hydrogen be placed in the group 17 of halogens or group 1 of alkali metals in the modern periodic table? Now, answer to this is hydrogen's atomic number is 1. Hence, there is only one electron in its outermost shell. So to become stable hydrogen, it loses the electron and makes one positive charge. Remember friends, when the atom loses electron, it achieves positive charge. Therefore, hydrogen, instead of keeping it with halogens, it should be kept with alkali metal groups. Now let's go into more details. Apart from these 7 rows, 2 rows are shown separately at the bottom of the periodic table. These are called as lanthanide series and actinide series respectively. There are 118 boxes in the periodic table including the 2 series. It means that there are 118 places for elements in the modern periodic table. Very recently, formation of few elements was established experimentally, and thereby the modern periodic table is now completely filled. All the 118 elements are now discovered. The entire periodic table is divided into 4 blocks, and they are called as S block, P block, D block, and F block. The S block contains group 1 and 2. The group 13 to 18 come under P block. The group 3 to 12 come under D block, while lanthanide and actinide series at the bottom they form F block. The D block elements are called transition elements. A zigzag line can be drawn in the P block of periodic table. The three traditional types of elements can be clearly shown in the modern periodic table with the help of this zigzag line. The metalloid elements lie along the border of this zigzag line. All the metals lie on the left side of zigzag line, while all the non-metals lie on the right side. Now let us learn how the electronic configuration of elements works in modern periodic table. Within a period, the neighboring elements differ slightly in their properties, while distant elements differ widely in their properties. Elements in the same group show similarity and gradation in their properties. These characteristics of the groups and periods in the modern periodic table are because of the electronic configuration of the elements. It is the electronic configuration of an element which decides the group and the period in which it is placed. Characteristics of groups and periods. The characteristics of groups and periods in the periodic table are understood by comparison of the properties of the elements. Various properties of all the elements in a group show similarity and gradation. However, the properties of the elements change slowly while going from one end to the other. For example, from left to right in a particular period. Now, this is a set of questions about groups and electronic configuration. Let's go through them one by one. Go through the modern periodic table, table number 2.7, and write the names one below the other of elements of group 1. This is pretty easy question. Have a look at the modern periodic table. There are 6 elements in group 1 of periodic table, and they are lithium, sodium, potassium, rubidium, cesium, and francium. You can see them in the left column of the periodic table. All these elements have just one electron in the outermost shell that surrounds the nucleus. The elements in group 1 are often called as alkali metals. Hydrogen is an element with only one electron on the outer shell, but it is a bit special, so it's often drawn on its own. Next question is, write the electronic configuration of the first 4 elements in this group. Now this diagram shows 4 elements starting from lithium. If you take hydrogen as the first element, then it's not included here, but hydrogen structure is electronic configuration is very simple. It's got only one electron in the shell, just one shell. The lithium has got 2 shells, and then you have sodium and potassium. So sodium has got 3 shells, potassium has got 4 shells with 1 electron in the outermost shell. The first shell will have 2 electrons. The second shell will have 8 electrons, and the electrons will go on increasing with increase in the order of the shell. The atomic number for hydrogen is 1, for lithium is 3, sodium it's 11, and for potassium it's 19. To write the electronic configuration, we'll need to know the number of electrons that is equal to the atomic number of that element. So accordingly, you can draw the diagrams for electronic configuration. We can easily make out the number of electrons in the outermost shell of all these group 1 elements is 1. That is the valence electron. And the valence electrons are defined as the number of electrons that are present in the outermost shell. So that's the similarity in group 1 elements. And same is the answer for question 4. It says how many valence electrons are there in each of these elements? It's 1. Now students, let's move on. You'll find that the number of valence electrons in all these elements from group 1, that is family of alkali metals, is same. Similarly, if you look at the elements from any other group, you will find the number of their valence electrons to be the same. For example, the elements beryllium that is Be, magnesium Mg, and calcium, that is Ca, they belong to group 2. That is the family of alkaline earth metals. There are 2 electrons in their outermost shell. Similarly, there are 7 electrons in the outermost shell of the elements such as fluorine, chlorine, and they come from group 17, that is the family of halogens. While going from top to bottom within any group, 1 electronic shell gets added at a time. From this we can say that the electronic configuration of the outermost shell is characteristics of a particular group. However, as we go down a group, a number of shells goes on increasing. That's pretty clear. Now let's go through these important facts. Uranium has atomic number of 92. All the elements beyond uranium with atomic number between 93 to 118 are man-made, artificial. All these elements are radioactive, they are unstable, and they have a very short life because they are radioactive. In modern periodic table, elements are arranged in an increasing order of their atomic numbers. Vertical columns are called groups, and there are 18 groups. The chemical properties of the elements in the same group show similarity and gradation. Horizontal rows from left to right are called periods. There are in all 7 periods. The properties of elements change slowly from one end to the other end of the period, from left to right or right to left. Now that's your modern periodic table. This is very important table, and as we have already discussed, there are groups and there are periods and there are these elements arranged in each box. There are 118 of these, and every box has got atomic number, the symbol of the element, the name of the element, and atomic mass of the element. So study this well. As I said, print a copy of this, do a photocopy, and put it on the board or on the wall where you study. Know this by heart. Now we'll learn more about this in next part, which is part 3 of this chapter. You will find it on a YouTube channel. Take care. Bye bye.